In these Masters of the Air clips, we see B-17 ball turret engaging in air-to-air combat. The gunner is defending the bomber from German interceptors. The intent of this video is to fact-check the series ball turret equipment, features, and usage in combat. We will identify 5 or so ball turret questionable series issues. We discuss the Episode 3 ball turret drop event in this video. We will need to unpack Episode 3 clip, the trap ball turret gunner narration, in a separate video. The ball turret is but one of the 9 B-17F model gun stations. The upper and ball turrets are powered and computed-sighted gun stations. Powered turrets reduce the effort required in gun manipulation in a slipstream, and computing gun sights increase both the range and accuracy. The Sperry ball turrets were integrated into both the B-24 and B-17 bombers. The main difference is the ball turrets were retractable in the B-24s and non-retractable in the B-17s. This schematic shows the ball turret's position while stowed and deployed in the B-24 airframe from a Briggs manufacturing document titled Lower Ball Turret. This image shows the non-retractable mounting of the ball turret on a B-17 airframe. Computing gun sights eliminate target guesswork by accounting for the bullet's drop, lead, drift, and aircraft speed differentials in both the vertical and horizontal directions, as shown on this graphic from a declassified 1944 U.S. Navy training course document titled Aircraft Fire Control. The gunner tracks the enemy aircraft with the gun sight reticle and, when within range, depresses the gun's triggers. The bullets will follow this path, striking the target here. This page from a 1944 B-17G Field Service Manual outlines characteristics of the Sperry ball turret. A hand controller unit rotates a turret up to 45 degrees per second in azimuth and 30 degrees per second in elevation. The turret's movement is controlled by a self-contained electrohydraulic motor unit. The system does not tap into the plane's hydraulic system. Either hand controller thumb trigger fires both machine guns. His left foot operates the K4 gun sight's target range out to 1,000 yards. His right foot operates the push-to-talk microphone switch. The turrets have a cutoff feature to keep from shooting your own plane structure or propellers. This image from a 1944 Handbook of Instructions for Lower Ball Turret shows the fire cutoff zones. This presented a blind spot that German bomber interceptors exploited. The B-17s had a 2-to-1 disadvantage when attacked from the 12 o'clock low direction, as discussed on this page from a 1944 Headquarters 20th Air Force document titled Combat Loss and Damage in the 8th Air Force. This blind spot coverage was somewhat mitigated by the incorporation of chin turrets at the end of 1943. The chin turret reduced the 12 o'clock low disadvantage to 1.25 to 1. Unfortunately, the series does not show B-17s with this combat-effective gun station. Additional features of the ball turret are shown on this page from a 1944 Kingman Army Field Training document titled Sperry Lower Ball. The turret weight equates to 1,290 pounds. It is constructed from cast aluminum, plexiglass, tempered glass, and some steel armor. The turret's arc travel is 360 degrees in azimuth and 0 to minus 90 degrees in elevation. The turrets are armed with 2 Browning M2 50 caliber machine guns. The gunner's backrest and seat are fabricated from armor steel plates. The turret shape makes perpendicular projectile strikes uncommon. This page from a B-17 Pilot Training Manual outlines the armor zones of protection of the ball turret. The armor is designed to stop a 30 caliber bullet. The gunner's seat is fabricated from a 0.6-inch thick steel plate, and his lower back support is 0.25-inch thick steel. The turret hatch is 0.25-inch thick cast aluminum and is considered part of the armor system. Since his lower legs are inside the machine guns, they provide some degree of shielding. The linked cartridge belts are overlap draped into the ammo cans above the gunner, which also provide a degree of protection. We can shade the armor or shielding parts in red. As you can see, he is pretty well protected, which is why this is one of the safest crew stations on the bomber. The machine gun spent casings and links are jettisoned out of the turrets by these openings, which can be seen in this clip. This clip shows B-29s dumping the expended casings and links for a clearer representation of what we should observe. The spent shell casings and links were a significant source of bomber damage, as shown on this table representing sources of bomber damage from a 1947 U.S. Air Force Historical Studies document titled The Combined Bomber Offensive, January 1st through June 6, 1944. This row represents the incidence of bomber damage from spent shell casings and links, which exceeds the incidence of damage from bullets. Each gun is fed by 500 link cartridges, as shown on this table from a 1945 AAF Air Technical Services document titled Tactical Planning. Each gun's rate of fire is up to 14 rounds per second, as defined in this 1944 AAF Gunnery School Manual. This implies the turret's duration of fire is around 36 seconds. The gunner was not allowed in the turret during takeoff or landing. Once airborne, yet below 10,000 feet, the turret needs to be rotated, barrels pointing straight down. The turret should look like this. The gunner will manually rotate the turret's elevation handle from inside the fuselage so the barrels point straight down, exposing the hatch inside the fuselage. Open the turret door, get inside, connect the safety strap, and close the door. Some crew members could fit a parachute inside the turret, most could not. Connect to the plane's 3 crew systems: oxygen hose to the oxygen regulator, heated suit plug to the rheostat, and the comms microphone and headset cables. The gunner places his left heel in the gun sight range stirrup and his right heel in the comms push-to-talk stirrup. Under his right heel is the azimuth gauge. This will tell the gunner the turret's position relative to the plane by a clock system. The control handles move the turret. The controls are inverted. To point the barrels to the left, rotate the handles to the right. To point the barrels to the right, rotate the handles to the left. To elevate the barrels, pull the handles down. To depress the barrels, push the handles up. The higher the deflection, the faster the barrels rotate, up to 45 degrees per second in azimuth. The triggers are on top of the handles and are operated by the gunner's thumb. I believe there's a misconception that the turret movement is controlled by some foot action. This seems to be based on the 1985 Amazing Stories episode, The Mission. Turn on the turret's main power switch. To chamber a cartridge, the gunner will crisscross his arms and pull on each of the charging handles twice. Don't ride the cables, let them snap back. We're ready to test fire the guns, test one at a time. Turn on the left gun switch. This provides power to the gun's firing solenoid. Point in a safe direction and test fire. Repeat for the right gun. These switches are also the gun safeties. Turn the switch on when ready to fire. Turn on the K4's gun sight. Adjust the reticle brightness. Characteristics of the Sperry K4 gun sight are shown on this page from a 1944 Army Air Forces Material Command document titled Index of Army Aeronautical Equipment, Volume 5, Armaments. The computing and ranging systems solve a ballistic solution for the bullet, ensuring more bullet strikes. The unit weighs 25 pounds. The Sperry ball turret's K4 sight is virtually identical to the top turret's K3 sight, as discussed on this 1944 Aircrew Gunnery Manual. The K4 is an upside-down version of the K3. This is my homemade upper turret controller and K3 gun sight show and tell display to aid in discussion. Once the gun sight's reticle is illuminated and the brightness is adjusted, and if needed, adjust the polarized sky filter. The gunner will need to identify the wingspan of the enemy aircraft from memorized tables. The wingspan of an Me-109 equates to 32 feet 7 inches. The gunner will need to input this value into the gun sight's target dimension knob, which is located here on the K3 sight and here on the K4 sight. Next, he will continually frame the plane's wingtips with the sight heads illuminated to vertical lines. The upper turret gunner controls the distance between these lines with the range grip. The ball turret gunner controls the distance between these vertical lines with his left foot operation of the spring-loaded range pedal. Now, the compensating gun sight has the range data to solve a ballistic solution. This image also shows the turret's overboard ducting for the spent casings and links. This image shows the K4's gun sight ranging images for head-on and non-head-on attacks. For non-head-on attacks, just draw an imaginary circle at the plane's wingspan. This page outlines proper ball turret firing guidelines from a 1943 Handbook of Operations and Service Instructions, Caliber 50 Automatic Computing Gun Sights, K3 and K4. Once the wingspan has been input, start tracking the target. Open fire with short 20-round bursts when the target is within 1,000 yards. Don't hold the trigger down for 13 seconds of continuous fire like in the sped-up Amazing Stories episode. If the target is within 200 yards, use a flip-up iron sight, like seen on this deployed K4 gun sight. If the motor does not respond to hand controller commands, the gunner can manually rotate the barrels down with an internal elevation crank, like Babyface tried in episode 3. These are the features I would expect to see. No barrel muzzle sight post, armored seat with rheostat and oxygen regulator attached, spent ammo and links dumping, short 20-round bursts around 1.5 second per burst, no tracers after episode 6, turret rotation no faster than 45 degrees per second. In addition, K-Fork gun sight head and sky filter, flip-up sight stowed, left heel resting on gun sight stirrup, right heel resting on comm switch stirrup, charging handles exposed. Let's take a look at the series ball turret 5 discrepancies found, ranked in order from significant to nitpicky. Item 1. The turret's rotational tracking speed is too fast. The turret's rotational speed in this clip equates to around 80 degrees per second. The speed of the turret in the clip is 78% faster than the actual turret's maximum speed. This clip shows a real turret's rotational speed of around 45 degrees per second. Item 2. The muzzles are fitted with sight posts. None of the turret barrels were ever fitted with sight posts. This is like seeing an artillery barrel fitted with a sight post. Like the upper turret, the non-CGI models did not have ball turret sight posts. Item number 3. No spent casings or links were dumped overboard during firing. Item number 4. Tracers are shown in episode 7. Tracers were eliminated 4 months earlier. The ammo loadout should be 100% armor-piercing incendiary. No tracers. Item number 5. No seat armor or charging handles are visible, and the heel stirrups are attached to the turret too low. If you have enjoyed this deep dive fact check review, please consider liking and/or commenting on the video.